I would like to thank you all for being here. The title of this work is Native Development and Implementation of IPv6 Experience in Argentina. It was done by GIDFIS, which means Research, Development and Training Group on Software Innovation. This group belongs to the National University of La Matanza, which is located in San Justo, Buenos Aires, Argentina. The authors of this work are Daniel Giulianelli, Víctor Fernández, Pablo Vera, Rocío Rodríguez, María Cornejo, Graciela Cruzado, and Pablo Cammarano, who designed this presentation and is speaking right now. I will list the different topics I am going to talk about. First, I will make a little introduction on IPv6, why this protocol appears, and its main characteristics and advantages. Second, I will show the kind of applications that can benefit from using IPv6. Then, I will show an example implementation in the research laboratory of GIDFIS, which has native IPv4 and IPv6 connectivity. Later, I will talk about the development framework that we use for developing native IPv6 applications. Finally, the conclusions and future work. So, what is IPv6? IPv6 is a new protocol which is gradually replacing IPv4. The necessity of creating a new protocol arises because of the depletion of IPv4 addresses. IPv4 addresses are composed of 32 bits that allows creating 4,000 millions of addresses. By the time when IPv4 was created, it was said that 32 bits were enough. However, nowadays with the expansion of Internet and in particular of mobile devices, we realize that more addresses are needed. On the other hand, IPv6 is composed of 128 bits, giving a number of 340 sextillions addresses, approximately. Apart from the large number of addresses, IPv6 has several advantages. First, flexibility. Header format is more flexible in order to speed up routing. Extensibility. IPv6 offers optimized support for new options and aggregations. This way it allows the introduction of improvements in the future. Packet flow identification. New flow label to identify packets from the same flow. Node fragmentation. The fragmentation is performed in the origin node and the reassemble is done in the final nodes, not in the routers like in IPv4. Mobility. Including the standard, it will allow changing the network without losing the connection. IPv6 includes more robust and efficient mobility mechanisms, which is going to benefit not only telephony and mobile phone users, but also good internet connections during plane flights. Multicast. In addition to unicast, anycast and broadcast, IPv6 incorporates multicast, possibility to send information to an insert recipient group. Auto configuration of final nodes, which allows devices to automatically learn an IPv6 address when connecting to the network. Applications. IPv6 allows the use of jumbograms, big data packets of 64 kilobytes. IPv6 includes flow labeling to give better real-time traffic support, for example in video conference. With these mechanisms, routers are able to recognize where the transfer packets belong. Plug and play. Ease connecting devices to the network. Configuration is automatically performed. When a device is connected to an IPv6 network, one or more addresses are assigned to it. Voice over IP. Two current problems that voice over IP services have are quality of service and network address translation. communications can result in low voice quality and difficulties to go through firewalls. The use of network address translation won't be necessary with IPv6 since it provides a big number of addresses. Furthermore, the new capabilities like plug and play, security, and quality of service will result in better voice connections. Let's talk about IP addresses distribution. There are 5 registries that manage IP addresses. These registries are controlled by IANA, Internet Assigned Number Authority, which delivers blocks of IP addresses to the different registries, and then they distribute the addresses to different countries. The registries work in different areas. For example, IRENE works in the USA and Canada, LACNIC in Latin America, AFRINIC in Africa, RIPE in Europe and part of Asia, and APNIC in the rest of Asia and Oceania. The main problem is that IANA has no more IPv4 addresses, so the 5 registries only have the remaining addresses to distribute to Internet service providers and governmental entities, among others. I will talk about the different kinds of applications that are benefit with IPv6. First, we have applications that handle large amounts of data. These applications will benefit from the implementation of jumbograms and also for the flexibility of IPv6. Audio and video streaming and digital telephony with voice over IP. These 2 types of applications take advantage of quality of service, which has improved in IPv6. Then we have cloud storage applications, mainly in smartphones. The mobility that IPv6 brings is something very important for these applications. Finally, we have applications related to e-learning. Multicast and peer-to-peer connections are IPv6 features that improve these kind of applications. Now I would like to talk about our experience with IPv6 in Argentina, particularly in our university. First, I will give a little explanation of IPv6 connectivity in Argentina. Nowadays, ERIU, Association of Network of University Interconnection, gives Internet access to member institutions. ERIU administrates RIU, University Interconnection Network. Operating costs of RIU are supported by member institutions and the Ministry of National Education. Network topology is full mesh, with a central point on Telecom Argentina data center. The central router is administrated by RIU, and it has internet connection using Telecom Argentina ISP, and access to advanced international networks through InnovaRed, National Research and Education Network in Argentina, and CLARA, Latin American Corporation of Advanced Networks. National University of La Matanza has 2 laboratories with IPv6 physically distance connected by fiber optic switches. In particular, one of the laboratories belongs to GIDFIS. Regarding hardware, the lab has a low balance router with multiple WAN interfaces. This router is used to connect local LAN to 2 WANs, one with IPv6 and the other with IPv4. Lab computers have Wi-Fi, so they are not wired to the router. Only the server is wired to the router. The lab also has a round table to allow researchers use the notebooks, so having a Wi-Fi solution is very important. Router configuration is simple, and the vendor has an online demonstration of the administration software. In this picture, we can see an example of router configuration with IPv6 connectivity. In the picture, we can see the connectivity map and how GIDFIS laboratory is connected to an IPv4 and IPv6 networks. The goal of this connection mode is to be transparent to the user, without noticing if connecting to an IPv6 only or to an IPv4 only web server. I would like to talk about software and the development of native applications. The focus is not only on hardware, but also on getting advantage of the new protocol features. Many applications designed for IPv4 were updated to also support IPv6. Future applications must consider IPv6 users, not only to support the protocol, but also to take advantage of the protocol. In a previous section, I gave you examples of types of applications that benefit from the use of the protocol. In order to develop IPv6 native applications, Microsoft.NET version 4 development framework was chosen. This framework has built-in functions for IPv6, like sending and receiving multicast packets. IPv6 no longer needs techniques like subnetting to send a packet to a set of hosts. Multicast feature allows sending a unique message to all the computers belonging to the same group. In this example, the first instruction allows adding an IP to a multicast group. The second instruction indicates that when data is sent to the socket, it will be sent to the entire group. GIDFIS is currently building an application that allows the following objectives: machine-to-machine communication, allowing a user to send text messages creating an internal chat for the lab. Send files to a machine, allowing a user to send a file to the select host over the network. Upload files to the server, improving by user backup. Share internet pages. A user can send a request to another user with a link with the current page of its browser. The user receives a notice and can click it to open the browser and see the page. This application will also use multicast, allowing all actions to be done individually for only one host or to a group of hosts. And now the conclusions. For the final user wanting to reach IPv4 pages having only an IPv6 connection is a frustration. And the same occurs if it has an IPv4 connection and wants to browse an IPv6 website. Connectivity must be transparent for the final user. Operating systems nowadays are ready to use IPv6 without having to enable it. But the first conflict is that not all ISP, Internet Service Providers, offers IPv6, and even having the ISP connectivity, not all network devices support IPv6. A correct network implementation must have IPv4 and IPv6 in a native way. On the other hand, developing applications supporting IPv6 native features will become vital in the near future, so it's really important to have resources trained in that area. Thank you. For any questions, if you want to contact GIDFIS, here is our email. You can also follow us on Facebook and Twitter. We will upload this presentation to our channel on YouTube. And again, thank you very much.